sector cut from a circle with radius 8 by an angle measuring 121 radians. Round your answer to the 100th. So this is a picture of a sector, right? It says the radius is 8 and the angle is 121 radians. And we don't know this side yet, but I know the perimeter is going to be radius plus arc length. That's the distance around that pizza slice. Okay, well, all I got to do is really find that arc length, and then I'm good to go. I remember that the arc length is equal to r times theta, provided that theta is in radians, which is what theta was given to me in this problem. So I just crunch some numbers and add them up. That's it. You know, you want to write it this way. Who can mental math this out? It's going to be 8 times 3.21 or 25.68. Boom, in your faces. Mental math. I mean, I wrote some stuff down, but it's like, that's how you do it with no calculator. I think that's the number, Allie, unless I goofed up my arithmetic. Mary says that's what she got, so it sounds good to me. Anybody else? Cool beans. Let's go. 2.4. All right, last time we met, we talked about that we can now represent an angle of any size by using the standard position method of drawing an angle, right? Bless you. So let's say we have some standard position angle. We'll call that angle theta. Pretty cool so far? I'm going to pick any point on that terminal side. I'm going to refer to that point as P, and that point's going to have the coordinates x, comma, y. Everybody so far so good? I notice with a little bit of imagination, if I drop a perpendicular here, I can imagine that I have a right triangle. We call a right triangle like this a reference triangle. The horizontal side of this triangle, what should its length be? Not a number. X. Very good. Yx. To get to P, how far over did we go? X over. So the vertical side should be Y. To get to P, we went X over, Y up. All right, great. What about the hypotenuse of that reference triangle? What should that be? Okay, so the square root of x squared plus y squared. That's a lot of words, so I'm going to just abbreviate that with the letter r. Everybody cool with that? Note that r is also could be called the distance from that point P to the origin. Everybody's cool with that? We notice it's the same thing, the Pythagorean Theorem and the distance formula. Basically the same thing. All right, so using what we have here, sine is opposite over hypotenuse. So I could write that as y over r. Cosine is adjacent over hypotenuse, so x over r. Tangent is opposite over adjacent, so y over x. Cosecant is hypotenuse over opposite, r over y. Secant is hypotenuse over adjacent, r over x. And cotangent is adjacent over opposite, or y over x. What did you just do, Mr. Kulik? Look at this. What have we done? This is sine, cosine, tangent, etc. defined in terms of a point on the terminal side of a standard position angle. Wait, what? This is great news. We have just broken the shackles of geometry. No longer are we tied to the acute angle in a right triangle. We can now use sine, cosine, and tangent on angles of any size because I can write a standard position angle of any size. All I need is a point off that terminal side, and I can now find sine, cosine, tangent, etc. Whoa. Whoa. Now, a couple of things to note here, right? SP is standard position, TS is terminal side. Should probably say this. Assuming the denominators are not zero. Why don't I have to bother with that for R? Why can't R be zero? It's the distance from a point on the terminal side to the origin. I have to pick a point on just the terminal side. I can't pick it at the vertex because that's terminal and initial. So I can't ever pick something at 0, 0. It's always going to be somewhere. Distance has to be non-zero to have an angle, right? Or else you have no terminal side. That's nothing. Oh, all righty. Rock and roll. Let's go. Let's do an example without using our new definition. So let's say the point -3, 4 lies on the terminal side of a standard position angle theta. Find the 6 ratios for theta. All right, well, I guess we'll start by drawing a picture. It's usually a good place to start. So I'll plot the point 3 or -3, 4. And I guess I'll draw a standard position angle. Everybody okay with what I did there? Just to start. So this is our point P. So I'm going to draw in my reference triangle. What is the horizontal side of that reference triangle got to be? -3. It's got to be the same value as x. Whoa, Mr. Kulik, how can a triangle have negative side lengths? It's because it's not a real triangle, guys. It's like a hypothetical triangle. And the vertical side should be 4. How am I going to find the hypotenuse? Pythagorean Theorem, right? Or that r is equal to the square root of x squared plus y squared. Word of caution when you're typing something like this into your calculator. What should -3 squared equal? +9. Okay, -3 squared. Type into my calculator. How come I'm not getting, I got -9. Is my calculator broken? No, you are, because you didn't text your calculator to do what you wanted it to do. The calculator is going to follow the order of operations strictly. The negative sign comes at the multiplication order in the order of operations. So it did the exponent first and then made it negative. What you meant to tell your calculator to do was make it negative and then square it. Be careful. I see students oftentimes, even at this level of course, making that kind of calculator mistake, particularly on problems like this. Okay, I got all my side lengths in for my triangle now. I got my values for x, y, and r, right? So now I'm just going to use my formula. Sine is y over r. Oops. Cosine is x over r. Tangent is y over x. Cosecant is r over y. Secant is r over x. Cotangent is x over y. Dunzos, Mr. K. What do you think? We're going to have to memorize those new definitions for sine, cosine, and tangent? Yeah. But, here's the dealio, though. It's really no different than the other definitions. Just instead of opposite, we're writing y. Instead of adjacent, we're writing x. Instead of hypotenuse, we're writing r. So if you know SOHCAHTOA, you just have to remember those translations, and it's still the same thing. No big deal, right? Don't memorize it fresh. Memorize the cheat code to translate what you already know into the new thing. That's what I would do. All right, what if I ask you to find cosine of 150 degrees without your calculator? Mr. Kulik, can't do that. It's not an acute angle. Yeah, you just have to use the new definition, guy. It'll be okay. All right, fine. So start by drawing myself a picture. So I'll draw my standard position angle for 150. When I'm drawing this, what's Mr. Kulik really concerned about? That you just get it kind of in the right quadrant, right? So the terminal side should be in which quadrant? 2, because it's 90 degrees for quadrant 1. Then we're going to do 60 more. Should it be less than half or more than halfway through quadrant 2? More than half. That's all Mr. Kulik's looking for on something like that. Okay? So there I just drew the standard position angle for 150 degrees. Everybody cool with that? Okay. I'm going to pick some point P. well, I'm just going to write like this. We'll fill it in a minute. Going to build out my reference triangle. What is that angle down there got to be?
30.
Great. How'd you know that? So linear pair with 150, right? Remember that term from geometry? Two angles that split a line in as a linear pair. They have to add up to 180. So in that case, what's this angle got to be?
60.
Uh-oh, what do we have?
30, 60, and then 90.
30, 60, 90 triangle. So I know the side lengths of a 30, 60, 90 triangle appear in the ratios a root 3, and 2a. Everybody's okay with that? Who likes those a's in there? Nobody. Here's the deal. Let's just pick a value for a and just plug it in. Gets rid of the a's. Mr. Kulik, why can I do that? That seems ridiculous. Here's why you can do that here. Can we pick p to be anywhere we want on that terminal side? Yeah. So we're just going to pretend we've picked p so that the a is this specific value. Everybody happy with that explanation? What value of a do you suppose Mr. Kulik's going to want to pick? 1. Yes, of course. Oh boy, that erased more than I wanted. That all look good to you guys? You should say no. There's still a little problem. What quadrant is P in? Quadrant 2. So the x-coordinate should be negative. Everybody happy there? All right, now I'm good. So if I do cosine of theta, that is x over r, dunzos. Drawing the picture is the hardest part, Mr. Kulik. Yeah, that's just, you know. It has its problems, but you get really good at it after you do it a couple of times. It's not so bad. Everybody, any questions here before we move? All right, cool. So this process still has one more step we're going to tack onto it. What's the downside of the process we've described but right now? If I was finding cosine 150 and Christian was finding cosine 150, we could both pick a different p on the terminal side. And when we go to compare work, all our work is going to be different because we picked different p's. That's pretty annoying, right? Let's standardize how we're going to pick that p so that everybody's going to pick it the same way. Sound good? We're going to decide to choose our p such that the distance, not the distinct, come on, one note, between p and the origin is, what length do you suppose we're going to pick? 1. Yeah, you're right. Okay. Well, what consequence does that have? Let's think about this for a minute. Suppose I consider all possible standard position angles, and I want to draw in all their possible p's. What shape is that going to make? Yeah, so we'd have like one here, one here. All of these are about 1 unit from the And what do we end up with? As my man back there stole my thunder on me, this is a circle. And what's the radius? Very good. We have a name for this. We call it a unit circle. Wait a minute. Hold on a second. If this is a unit circle, if the distances to all these points is 1, if I go back to my definitions, sine was y over r. But what is r now? 1. And cosine is now, was x over r, now it's x. Cosecant was r over y, it now becomes 1 over y. Secant was 1 over x, was r over x, now it becomes 1 over x. But what about tangent and cotangent? Yeah, those don't change, right? Because r was not involved. Look at this. Look at this. Sine is y, cosine is x. That means that any point here on my unit circle has the coordinate cosine theta, comma, sine theta. What? What did we just do? That's a third definition now that we have for sine, cosine, and tangent, etc. Great. Yes. That's wonderful. So, we have 3 definitions, right? We have the geometry definition, sine, cosine, and tangent defined on acute angles inside a right triangle. You have the standard position angle definition, where sine, cosine, and tangent are defined by a point P located somewhere on the terminal side of a standard position angle. And then our third definition, where sine, cosine, tangent, etc. are defined from the points on a unit circle. Depending on the context, you may want to use any one of these 3 definitions during your time in the course. Oftentimes, a problem will be easier to do one way or another way, or there may be problems where you want to combine and think about different parts of it using different definitions. So you want to know all 3 and be able to use all 3 definitions kind of interchangeably. Now let's go and construct ourselves a little helper. So notice back here, when we found the value of cosine 150 without a calculator. Sure. We were able to do this because the reference triangle we created was one of our special right triangles. It was a 30, 60, 90. Everybody agree with that? So any angle that is going to create one of these special right triangles as our reference triangle, we can find the exact value for it. Everybody cool with that idea? Let's do that right now for all the possibilities, record all that information so we don't have to do it every time this pops up, because they pop up a lot. We can just now look it up off a sheet. Sound good? All right. Thought I moved those in there. Guess not. Grab them from over here. Choop. 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 Copy and paste. La la la. Copy and paste. La la la. All right. All right, so what we're looking at is a blank unit circle. We're going to go ahead and fill in all the values and the points on this unit circle together one time. Won't ever ask you to do it again. Once we've done it, we can use it though. Okay. So the first angle I'm going to draw is 0 degrees, whose point lies here. What's the coordinate for that point? 1, 0. Great. The next point I'm going to draw is this point here. What's that angle? 90 degrees, and the point is 0, 1. Now we'll do this point over here. What's that angle? 180, and the point is -1, 0. Oh boy, a lot of different answers on that one. And we'll, come on, no. Now we'll do this one. What's this angle? 270, and the point is? Yep, good. All right. So those were the straightforward, easy ones where there's no triangle even possible. We call those angles quadrantal angles because the terminal side lies on a quadrant, one of the x or y axis. Let's do the 45, 45, 90 reference triangle problems first. Obviously, 45 degrees creates a 45, 45, 90 triangle. That's this mark right here. So there's my 45, 45, 90 triangle I'm going to build. Okay, just sketch it out over here. So the sides of a 45, 45, 90 triangle are A, and A root 2. But what does A root 2 have to equal? Has to be equal to 1 because that is a radius of my unit circle. That tells me A has to be 1 over root 2. So my x side has to be 1 over root 2. And my y side has to be 1 over root 2. Everybody happy there? The next angle that I can draw that makes a 45, 45, 90 reference triangle is here at 135 degrees. Notice that we're in quadrant 2. What can I say about the coordinates in quadrant 2? The x's are negative and the y's are positive, and the x and y coordinates are going to be the same as the others, just with different signs, possibly. And then our next one is down here. This is 225. We're in quadrant 3. What can I say about the things in quadrant 3? The points in quadrant 3? Yeah, both of them are negative. And then the last one is 315. That's in quadrant 4. What can I say about the points in quadrant 4? X's are positive, but the y's are negative. Everybody happy here? Okay, let's do the 30, 60, 90 ones. I'm going to do the 30, 60, or start with the 30, 60, 90s, whose reference angle, that's the angle at the bottom of our reference triangle, is 30. So there's our reference triangle. Again, I know the hypotenuse has to equal 1. So A has to be 1/2. So my x here has to be root 3 over 2, and my y has to be 1/2. I get another 30, 60, 90 where the 90 is the reference angle over here at 150. Sorry for those listening at home. You got a loud sneeze right there. And then I got another one here at 210. And then my last one over here at 330. Everybody cool? Now we'll do the 30, 60, 90s where the 60 is our reference angle. Again, A still has to be a half. So this becomes root 3 over 2 for y, and x becomes a half. So I'll just go fill that stuff in now. Is everybody okay with what I'm doing? What is this just allowing me to do? Allows me not to have to break out these special right triangles every time I have to do something, right? Instead of writing everything down, I can just look it up. Oh, Boise, I forgot to fill in the angle measures. I got so excited. And now OneNote is like lagging all over the place on me. All right. Now, Mr. Kulik, it still looks like there's some unfilled in blanks on this unit circle. Guess what's going to go in those blanks? The radian measures, yeah. So 0 pi, or 0 degrees is 0 radians. 30 is pi over 6. 45 is pi over 4. 60 is pi over 3. 120 is 2 pi over 3. 135 is 3 pi over 4. 150 is 5 pi over 6. 210 is 7 pi over 6. That's 5 pi over 4. The next one is 4 pi over 3. Then we have, oops, I forgot the pi here. And the pi over 2 up here. Mr. Kulik, I just got going fast, guys. Got a 3 pi over 2 down there. 5 pi over 3. 7 pi over 4. And 11 pi over 6. All right, ready to rock and roll. You notice also in the OneNote, I typed in, filled out one. The only difference between the one we just made and the one that I typed out is I rationalized 1 over root 2. Since it felt like it was like a final answer or whatever going in there. All right, let's just do a couple of quick examples how we use the unit circle to do find values of sine, cosine, and tangent. And I got one more example after that, and then we're out of here. Sound good? Well, it's homework quiz time anyways. All right. So, sine of negative 30. First thing I'm going to do is I'm going to look at my unit circle and see if negative 30 lies on there. Does it? No. Mr. Kulik, what am I supposed to do then? Well, is it coterminal to something on the unit circle? Well, I don't know. You didn't say that yet. Well, I'm saying it now. How do I find if an angle coterminal to this? Add or subtract 360. In this case, should I be adding or subtracting? Adding, because negative 30 is smaller than anything on my unit circle. So if I do that, I see 330. That I do recognize as a unit circle angle. So I'll go and find 330 on my unit circle. I'll remember that sine is the y coordinate. So sine of negative 30 must be negative a half. Done. What? That's it? That's it. Slick. All right. Let's say we have tangent of 13 pi over 6. What, Mr. Kulik? Radians? Really? Yeah, man. Why not? Is that on the unit circle? Nope. Is it bigger or smaller? Bigger, so I should be subtracting 2 pi. Gives me pi over 6. Everybody's okay there? Tangent. So I guess I'll go next and locate tangent pi over 6. I remember that tangent is y over x. So that's going to be 1/2 over root 3 over 2. When I reduce that, I get 1 over root 3, which I rationalize into root 3 over 3. Dunzos. Mr. Gulick, this is pretty quick. I haven't had to draw a triangle yet. I know. All right, one more. Secant of 495. Cool, like that's too big. Well, check if the coterminal. All right. You told me that. Secant 135. Oh, that's one of them. Where's that guy at? Right there. Remember that secant is 1 over x. So I'm going to need the x coordinate. So when I make the reciprocal of that, I get this. And if I reduce that, what do I get? Square root 2, right? Because 2 is square root 2 squared, right? Everybody's cool? We feel good using the unit circle? So a couple of examples to burn through. There's a bunch more practice in the homework and whatnot. We'll get some more practice on it if you don't feel good yet. But by the time you finish the review, if you don't feel good, then we got a problem. Okay? You should have lots of practice, though, coming up. Some of us will catch on quicker than others, and that's okay. My last example. And then we're outie. Let's say we ask you to find sine theta if cosine theta is 5 over 7 and cosecant theta is negative. What do I do with this, Mr. Kulik? How am I going to use the unit circle to do this? You're not, really. Well, that's okay. We'll start by drawing our standard position angle. The first thing I need to do, though, is figure out where that terminal side lies, right? What quadrant is it in? Well, cosine is equal to 5 over 7, and cosine is the same as x. And that really is just telling me that x is positive. What quadrants is x positive in? Well, 1 or 4. Everybody agree with that? Cosecant, I know is equal to, well, I know it's negative. And cosecant is x over, or sorry, I wrote cosecant? Okay, whatever. I think I was supposed to write cotangent there in my example. I'm going to update that. Cotangent is x over y. And the x in this case I know is 5 over 7. So if 5 over 7 divided by y is negative, what does that tell me about y? Has to be negative. Y is negative in quadrants 3 and quadrants 4. So where is my terminal side have to lie? Quadrant 4. Whoop. Everybody okay there? I'll pick my point P. I know that if I use the point on a terminal side of a standard position angle definition, I know this side is x and that side is r. So cosine being x over r makes those sides 5 and 7. I can then use the Pythagorean Theorem to find the y side. So square root both sides. And then I need to reduce the square root of 24. So I can write as a factor of a perfect square. The 4 is a perfect square, and 4 times 6 is 24. So that makes that side 2 root 6. That all look good to you guys? Shouldn't say yes. Yeah, I'm missing a negative, right? That y side needs to be negative. So, using my point on a terminal side of a standard position angle definition, sine is y over r. And I'm done. What's probably the most difficult part of that? Getting the terminal side's location, figuring out which quadrant your angle needs to be in. If you goof that up, the positives and negatives will get all goofed up. That's the consequences if you mess that up, what will happen. Okay, that's it for me. Any questions before we hand out this homework quiz? Okie doke.